live streaming. Welcome, everyone. We are live on the ISLE Global YouTube channel, and you are watching the second Sustainable Water Solutions webinar on resource recovery and circular economy. I'm so excited for everybody who's tuned in today with us, because this is frankly one of my favorite topics to talk about. And we've got a lineup of very knowledgeable speakers. Oh, sorry. I apologize for that feedback if you heard it. Very good. And we've got a lineup of very knowledgeable speakers about this subject. And our agenda for this afternoon is, first we'll hear from one of our partners in delivering this webinar series from PBSP Water Alliance. And then I will be talking about an overview of the circular economy and resource recovery. And then we'll hear from Karen on the technology solutions for making these happen. And then we have two exciting case studies, one from Singapore and one from the Philippines, on resource recovery and circular economy. And finally, we'll have Q&A and closing. So without further ado, I would like to give the floor to, oh, sorry, before that, Elvin, just a few reminders to our viewers that if you've got questions or comments, please type them into the YouTube live stream chat. You should be able to find that in the YouTube app or website if you're watching through your browser. And for those who would like to receive a certificate of attendance, please follow this link and accomplish the webinar evaluation survey. You will automatically receive a certificate after that. And at any time that you would like to go back to this webinar, you can view it on demand. It will stay on in the ISLE Global YouTube channel. And please hit subscribe for new video updates. We do upload a lot of great content, including our COVID-19 webinar series and the Water Action Platform webinar series. And finally, for those who missed the very first Sustainable Water Solutions webinar, which was all about trade waste and wastewater management, you can go to this link and view that webinar on demand. Right, our first speaker to give us a warm welcome, PBSP Water Alliance Deputy Executive Director and Acting Executive Director, Elvin. Elvin?
Thank you, Yang. Before I begin, let me just acknowledge Mr. Ryan Yuen, Deputy Director of Public Utilities Board or PUB Singapore, Noel Melarpis, our Sustainability Manager of Pepsi Cola Products Philippines, Clode, Senior Consultant of Isle Utilities, Yang Villa, of course, Head of Philippines for Isle Utilities, fellow water resources, sustainability advocates, distinguished guests, ladies and gentlemen. Good afternoon to everyone. Let me welcome all of you to this learning event on resource recovery and circular economy in water and wastewater stream, the second part of the Sustainable Water Solutions webinar series. This is an undertaking of the Water Alliance with Isle Utilities, an alliance member and vice chair of the Water Footprint Reduction Cluster. The first webinar last May 8 focused on trade waste and wastewater management. In case you missed this and would like to view the recording, we will flash later on where you may access the video. For those of you who are new to Water Alliance or to this webinar series, the Water Alliance is one of the multi-sectoral partnership and advocacy platforms of Philippine Business for Social Progress, or PBSP, and is committed to make significant contributions that can complement government's effort to address pressing water security issues. We have members from the business sector, government, academe, and non-government and civil society organizations that are involved in various ways through task-based clusters that execute the groundwork in areas of strategic importance to Alliance. So there are 4 clusters, and these 4 clusters are: number 1, water for waterless communities; number 2, water footprint reduction; number 3, water governance and policy reform; and number 4, water research and database. Isle Utilities, on the other hand, is a technology and innovation consultancy specializing in clean technology. Isle has a proven track record in accelerating the development and commercialization of emerging technologies through their Technology Approval Group, or TAG, the industry forum that drives innovation. Our topic today is focused on resource recovery and circular economy. Water resource recovery is the new term for wastewater treatment and a key measure of water efficiency. The circular economy approach, on the other hand, is designed to keep materials at their highest value for as long as possible by repurposing and recycling them once they have reached the end of their operational lives. As we are all well aware, water is fundamental to meeting basic needs of all living things. This service to life, including human consumption, cannot be satisfied by substituting water with other measures or materials. Water circularity is impacted by human action when we alter the natural water cycle, such as by utilizing fresh water above its rate of replenishment, accelerating water loss through inefficient irrigation and distribution methods, and polluting water and limiting its utility for other users, among others. Such outcomes have adverse impact on the natural water cycle and can result in economic and environmental losses or additional costs to meet the human needs. A study on circular economy for water stated that it is better to align the human water cycle with the natural water cycle through measures captured by 1A and the 4 R's. So the 1A is avoiding use, meaning rethinking products and services and eliminating ineffective actions. The 4 R's, of course, is reduce, reuse, recycle, and replenish. Replenish in particular by efficiently and effectively returning water to the basin. The function of water use in these loops can have multiple dimensions. Understanding these is fundamental to realizing the opportunity and enterprise potential of water and circular economy. To know more about this afternoon's learning session, our resource speakers will discuss circular economy, available technologies for resource recovery for wastewater, and presentation of two case studies from PUB Singapore and Pepsi Cola Philippines. Again, on behalf of the Water Alliance, PBSP, and Isle Utilities, welcome and thank you for tuning in to our second webinar series. We look forward to everyone's active participation and commitment for water resource sustainability. I will now turn over the screen to Yang to provide more information on circular economy for water.
Thanks a lot, Elvin. That was a very warm welcome, and Isle Utilities Asia Pacific is very happy to be in partnership with PBSP Water Alliance for this webinar series. Right, so my name is Yang Villa, and I am the head of the Philippines for Isle Utilities. I want to give you a quick overview of circular economy, though Elvin has done a really good job of defining that for us already earlier. The circular economy is an economic system that is deliberately designed to continuously and continually use resources and eliminate waste. And the circular economy is in stark contrast to the linear economy, which is the current mode of production and consumption today. We take resources, we make products out of them, and after using, we dispose and therefore pollute and generate wastes. Circular economy will take those resources into more productive uses by enabling their maximum, more optimal use in the economy. I'd like to share the 4 principles of circular economy that I learned from the Ellen MacArthur Foundation. If you'd like to know more about this topic, head over to their website. The first principle is that all waste in a linear economy is really just input or food for further industrial processes. So we'll see a lot of examples of that today, how we recover resources and take them into another aspect of production or process, and to make valuable stuff out of that. Second is that the circular economy should be powered by renewable energy, and that's a totally different topic altogether. But we will see a very good example today from the Philippines about plastic to fuel. And the circular economy also advocates ecological diversity, because this will result in not just social resilience of communities and our society as a whole, but also the resilience and sustainability of our ecological resources. And finally, to be able to do this, we must engage in systemic level thinking and not just act in silos. And I think the PUB Singapore example is a great case study of showing how to do this in a national scale. So the key message of the circular economy is that there's no such thing as waste. Anytime you see waste, it is really just unrealized inputs and unconverted value. And it's our job to figure out how to unlock and uncover that value. So this butterfly diagram is from the Ellen MacArthur Foundation. I'm not going to discuss it in detail. You can learn more about it from their website. But I want to focus on the left-hand side of this diagram. So the left-hand side is concerned with the biosphere, or the organic cycle, and the right-hand side is more concerned with the technical cycle, the inorganic gadgets and stuff and materials that we use. The water sector and obviously the wastewater stream really contributes to the left-hand side in making sure that we recover and recycle the resources in the biosphere. And we can do that through a lot of processes. The left-hand side of this diagram will also show you the interconnectedness of water, energy, and food in what we call the nexus. And a lot of the resources that we generate out of wastewater streams can actually be reused for food production and for energy production, as we'll see in our case studies today. So in the context of the water sector, the baseline for resource recovery and generating the circular economy is really wastewater collection and treatment. Not all the time, but it is for a larger scale of circular economy transitions, we do need wastewater treatment. And unfortunately, in the Philippines, this is not yet the case, because we have a great deal of cities and municipalities still not engaged in wastewater collection and treatment. We need to do better in doing that. The second point that we want to make across is that the circular economy may require us to create or facilitate new markets for products that are generated out of this new cycle. Let me just mention some of these new products that we can derive from sludge. And Karen later will talk to you in greater detail about this. But it includes biosolids, fertilizers, for example, biogas, phosphorus, nitrogen, and other precious resources and precious metals, cellulose, bioplastics, construction materials, and proteins, all of which can be reused into further industrial processes. Now, to be able for us to move from a linear to a circular economy, it often requires us to rethink not just the way we operate as a business, but the entire economic system. And this means that utilities have to move beyond the traditional business model and look at things beyond water service. And again, we'll hear from one of our speakers later how the PUB in Singapore is leading in this charge. So what are some of the opportunities, drivers, barriers, and enablers for circular economy? The drivers obviously are, as Elvin mentioned, could be environmental pressure, the fact that we need to recover more resources, given that they're scarce, and this is particularly useful for precious metals, for example, in the mining effluents, or even for water, especially for water scarce areas. Another driver could be financial returns. Many utilities can actually uncover value from the circular economy. And sometimes we have social and customer pressure because our customers are demanding us to be more ecologically friendly, to have more sustainability in our business practices. And you'll hear from Noel later on about how Pepsi is leading in that regard. But of course, for every barrier, every driver, there are barriers to circular economy, including sunk infrastructure. Sometimes it's very difficult for utilities to invest in new infrastructure when our current infrastructure is still in place, and we cannot justify, an expansion of the infrastructure landscape, or it will take time for returns to be recovered. Sometimes limited skills and capability are also a barrier in that we don't really know how to do this. We don't have enough engineers and scientists to make these processes happen in our company. But perhaps the biggest barrier to resource recovery and the circular economy is the fact that we have cheap energy. Cheap energy is the primary reason for the linear economy. And until we can get renewable energy to actually be at par, if not cheaper and more economical than our current sources of energy, then it will be very difficult to transition into circularity. But there are enablers for us to move from linear to circular economy. Number one is that governments can push for progressive legislation. We've seen this in places like Australia, for example, that they require utilities to recover some of these precious resources and materials from wastewater effluents. The other enabler, of course, is innovative technologies, which Karen will talk about later. And finally, we need to keep looking for new ways to do business and to fund circular economy and resource recovery projects to move forward with this new way of production and consumption. So that is a very quick overview of the circular economy. And how ISLE can help you in this regard is, as a consulting company, we can work with you to figure out what are the opportunities for resource recovery and circular economy in your organizations. If you are a utility or an industrial company, we can take a look at your processes and identify innovation opportunities and match you with appropriate and fit for purpose technology solutions. If you are a technology company offering some of these solutions into the market, we can help you find the best market for your products and services. And of course, our focus here is the Philippines, but we can also look for markets in Asia Pacific, in Americas, in Europe, and Africa, and everywhere else in the world, basically, that ISLE Utilities is present in. I do note that we do not sell the technologies on your behalf. We are not a distributor. We do not have licenses on these technologies, but we can help you develop the market and your business in new territories. And finally, we work with enablers of technology like government and investors to ensure that innovation happens in a consistent manner. Right, I think I've spoken too much, and I'd like to give the floor over to Karen to talk about resource recovery from wastewater. Karen, over to you.
Thanks, Yang. So resource recovery from wastewater. So I'm just going to give a quick sort of lightning dash through some of the some of the technologies that we've seen over the years. We've seen quite a few in the resource recovery area. So I'm going to run through by priority, which ones have been sort of the higher priority, which has been the lower priority. And it kind of depends on a couple of things that Yang's already talked about. So what is resource recovery? So it's been defined a couple of times here already by everyone, but we'll define it here as when energy or a material or a product is taken from waste and is reused. And it's becoming an important part of every business, really. And many companies might already be doing it in just a small way. And the three key areas that I think we've touched on already. So the physical product itself, what form is it in the waste stream? So if you got it and is easy to get to? Selecting then the right technology to manufacture the product. So actually getting it from the form you have, maybe into a form that's commercially viable. And then having a market. So having somebody you can actually sell that product to. So equally, it actually might be an internal reuse market within your manufacturing company or within your business, or it might be somebody external. So in terms of resource recovery potential, there are basically three elements that have to converge. And you have to ask yourself around quantity. So you might have all those three areas, and then you go ask yourself, can you concentrate up that waste in the waste stream? Do you have enough to extract it and make it viable? So is that viable? Is that cost of that technology to actually concentrate it up? Does it cost more to produce than it is for that market value? So you have to take into account then stuff like transportation costs as well. This will be different for all companies, and it'll differ within a company. It may even differ from site to site depending on what you're producing. As Yang said, we've undertaken a number of different projects in this space, evaluating waste minimization and resource recovery opportunities for various different businesses. So if you want more information on that, just feel free to reach out. In terms of the next one, so resource recovery products. You can see there's a kind of a wide range that we've looked at over the years. In a trade waste context, this will really depend on what actual resources are in your wastewater. And so this will depend on your manufacturing process. And so it'll vary from food and beverage, say, to electroplating. And they'll have different concentrations of different constituents. All these products, though, realistically can be recovered. Like I said, it will depend on those three factors that we talked about first, around how much you have of that product and the price and the technologies available. So if we move on to the first one, where you notice it wasn't quite included, there is water. So this is kind of the obvious one, and it should be already done essentially within your manufacturing process. It's by far the easiest to recover, and it has numerous enabling technologies. And there's obviously an existing market base. We all want water, we all need water. And again, that can be internally or externally. So I'm going to highlight a few of these technologies. This is a typical wastewater treatment train. So you may have a number of these stages, depending again on what type of process that you have and what you need to get your to meet your discharge limits. Primary processes include DAFs and clarifiers, and they'll produce water that's kind of suitable for maybe irrigation on site or on local farmland if you have that available. If there's a high degree of maybe COD, BOD nutrients, and you'll then need probably a secondary treatment. So you might have activated sludge, MBR, MABR, or various other variations on that. You'll get a much, if you have those sort of processes, you'll get a much higher quality. Typically that's can be reused then for cleaning around your site. But if you're a food and beverage manufacturing company, then there can be a concern over food safety and hygiene, and this usually kind of puts a roadblock on some of the reuse applications for water in that manufacturing area. So typically this type of water, even though it's a higher quality, it's only used in areas where there's minimal risk to any health and safety. So if you just click again, Yang. So an example of a secondary process here is the cleantech water process BioCleanse. So they have a treatment process which is basically encapsulated, bacteria encapsulated in what they call lenses, so tiny plastic capsules basically. So the advantage of these processes, this type of process in wastewater treatment, is it guarantees a sort of good water quality. They have the biocatalyst ensures that your biological process remains stable, and you don't get washouts, because I know with trade waste you might get very high fluctuations in water in that treatment process. So these bio lenses make sure that your bacteria is kept within that process, because it can be encapsulated within the bacteria within those lenses. So those sort of processes will give you a slightly step up, and they'll give you a more robust secondary treatment process to ensure you're getting that good quality water. Tertiary processes such as ultrafiltration and reverse osmosis will be your next step. So you'll be looking at producing like an ultra pure water that's suitable for complete reuse. So these sort of processes will give you a water that's equivalent to what you'd get from your local municipality. Advances in membrane and treatment waste treatment systems have led to some manufacturing sites actually reaching complete zero liquid discharge. So an example I've got here is the Polysera from Water Planet. They've developed a material that's not quite like other polymers. It's not quite like metal or ceramic, hence the Polysera name. So it's a much more robust polymer membrane compared to standard one. So if you have issues with pH, temperature, that sort of thing, they'll stand up to that type of treatment. If you are putting in membrane treatment, you'll obviously get a reject. So you might want to be reducing the volume of that reject stream. So an example of that type of technology to help you reduce down to get to that zero liquid discharge, perhaps is the CVAP. So the CVAP technology is it's a low cost evaporation process. So it enables the recovery of clean water as well as valuable materials actually. So once you've concentrated up that water, perhaps you can easily then recover those materials that may be in there. So that may be metals, or it may be salts, or something of those kind. So other sort of water recycling, basically biosolids and biogases tend to be the sort of the current largest resources recovered in wastewater treatment these days. And actually biogas is seeing the greatest growth, and that's probably being driven by electricity prices. So if we just cover biosolids first. So biosolids to land is a well-developed market, and actually in some areas there's no real driver for improving the quality of your biosolids. It may be other drivers such as transport costs, so that'd be dictating, or maybe you've lost your route to market as it is, lost your route to farmers, to land. Maybe you've got some sort of contaminant in there, or maybe you want to produce something with a higher commercial value, or something drier. Maybe the transport costs causing the issues. So if we have a look at biosolids in a bit more detail, so typically, I mean, the social biosolids might be coming from various stages of treatment processes. And it may just be actually from a soil liquid waste byproduct from a manufacturing process. So they tend to all be combined together. And so if you are looking for this alternative product, maybe than just putting that liquid sludge to land, you might be looking to dry or produce maybe a biochar or a fuel from that biosolids. So these are a couple of options anyway. So so if we move on just a little bit, a couple of clicks, there's next. So there's kind of two technologies here. So potentially you can reduce the water content. So if you dewater and you want to reduce the water content further that sludge, you may be looking at potentially the NPL process from Oxypel. So this is a new one on the market, and it's quite exciting. It's a self-desiccating pelletization process. So they have a drum pelletization, but doesn't use heat. So it's kind of interesting on that front. And then there's the Terra Nova hydrothermal carbonization. So this is kind of the other end. These guys are using heat, pressure, and chemicals, but they have an interesting recycling process that actually makes it quite efficient. They'll produce, so the NFL process will produce a pellet from the sludge, whereas the Terra Nova is actually, the hydrothermal carbonization process will actually sort of modify the sludge and produce a coal-like material. So both of these can be disapplied to land as an advanced fertilizer product, so drier, obviously concentrated NP, or they can actually be used as a fuel. So they could be used in a maybe a modified power station or in a cement kiln or that sort of stage. So there's some options here that you could be taking your sludge, though I will say that the use as a fuel will depend on the calorific value, so how much carbon you have in there. So if you have a manufacturing process that's actually producing a sludge that's got a very low carbon content, but maybe higher in that, then these sort of processes might not actually work. But there are other ones in our long list, but I'm not going to touch on them now. So if we move on to biogas, so like I said, this is also a well-developed market, and there's many drivers around this, sort of trying to get away. I think a lot of people are trying to get away from the reliance, perhaps on the grid. If you've got an unreliable power source, maybe you want to be able to buffer it with your own power. You also may want to reduce your greenhouse gas emissions or get an income from generating electricity that goes into the grid. Typically, it is electricity and then heat and steam that you're producing from that biogas that actually can be upgraded and injected into the natural gas grid. If you have one, you'll go open to it, or it can be even converted into hydrogen if that's perhaps something, a scheme that's happening in your area. Moving just on to having a look at biogas in a little bit more detail. It's typically produced from the sludge generated in various wastewater treatment processes. It tends to be done at the end of the treatment processes. There's a bit of development here in anaerobic processes. So if you just click again, please, Yuen. So the anaerobic processes are being developed at the moment, and actually the anaerobic MBR is a good example of this development. It's been around for a while, but it's a bit more difficult to actually operate correctly. It doesn't produce the same amount of biogas as you expect from anaerobic digestion, but it does produce a high quality effluent in a single step. Actually, Avocqua is one example of one of these companies that have developed a robust process. So the ADI technology is out there, and they've actually deployed it in a number of different applications around the world. So it's proven. But if you have a wastewater treatment process producing biosolids already, so you have a solid or sludge waste, and so it might be better for you to have an aerobic digestion. So this might come in a large scale, so maybe a tank, or a lot of times it can be a lagoon, and but it may also be on the small scale. So if you're actually a small scale food manufacturer, or even just a restaurant, you might be looking at some sort of containerized system potentially. So if you click the SEAB Energy FlexiBuster system, it's a containerized, small scale containerized system. So they'll take food waste generally, but they'll take any sort of organic waste, and they'll produce a small amount of heat, energy, and then of course a fertilizer product out the back end. So there's a wide range in that sort of digestion area. It doesn't have to be, you don't have to have a lot of sludge to make a large scale system in place. There's lots of options. Finally, though, there's a last option here, which is perhaps if you were looking to, maybe disposal is an issue, you've got nowhere to put it, landfill costs are high, maybe you're looking at maximizing your biogas production, so you're trying to recover as much biogas as possible from your organic stream, you might be looking at a thermal destruction process. So energy is an example of this. They're high temperature pyrolysis, and they convert the organic material into a syngas and a biochar. So the biochar can be used for various different applications. So it can be burnt, or it can be used as a soil improver, fertilizer, but you'll produce a higher amount of biogas from that process. So what else is there? So there's another long list of different options here. These are a bit more, depending on what you have in your wastewater. So all these different products will have different less urgent drivers, or different drivers in different markets, which will be less and more developed. So we're going to just look at nitrogen and phosphorus. So again, I know that there are a number of drivers here around nitrogen and phosphorus, mainly being around changes in discharge limits. So that's leading to more intensive look at what treatment processes might be available, and then the consequence of having more intensive treatment processes to get rid of your NMP is going to be you're going to have greater quantities of sludge, and that's typically where your nitrogen and phosphorus is going to end up. So there's going to be, I know this is going to be a growing area for a lot of companies in their trade waste. So to improve your sort of removal. So if you're looking at the sludge, so this SUSTEC process can remove it from various concentrated industrial waters or from reject water. So after you've dewatered your sludge, your NMP might end up in there. And they have a ammonium sulfate solution a process that produces ammonium sulfate and struvite, which both can be used as fertilizers. So it's a single process that can remove both the N and the P from the system. There's a large number of these type of technologies that have been actually developed in Europe in recent years due to their new biosolids legislation, requirements for them to actually remove the nitrogen and phosphorus. This has been driven by obviously reductions in raw sort of natural phosphorus that's available. Many of these technologies probably won't be relevant to the Asia Pacific market, but because of different conditions and drivers, but it does provide a huge amount of options. Alternatively though, the ClearAS technology, so this technology can remove nitrogen and phosphorus from the wastewater stream itself. So I quite like this one. This is an anaerobic, this is a advanced biological nutrient removal process. Basically it's an algae treatment process, and it's a vertical algae treatment process. They use clear perspex tubes, so they don't have issues with footprint. They can use LEDs if light is an issue to ensure that the algae grows, and then they have a specially designed microfiltration process that can actually then separate the algae from the water and produce a higher quality water. So this is a good option if you have still have NMP issues at the back end of your treatment plant, and you want to recover them. That algae then has numerous options. Then you can dry it, you can then put it into a digester, you can produce a fertilizer out of it. So yeah, NMP, a big one. So if we can move on to metals. Metal recovery, this tends to be very specific to certain industries. So electroplating, mining sectors, those are the sort of industries where these technologies are actually developed out of. And so therefore they're kind of mainly applicable for wastewaters with a high metal concentrations. The most popular metal is actually copper. So that's the one that most technologies can recover. Well, it tends to be associated with acid mine generally. They are starting to be able to recover metals in lower concentrations. So perhaps if you have more precious metals, so lithium is an example, anything that's one of those more rare earth metals that perhaps are being used in batteries, they tend to be more in favour when it comes to removing from wastewater. So chromophora is actually a good example. They're a great tech. They're into low-cost solution. They use phosphine ligands, so they recycle the phosphine ligands, I think, which makes them unique, and means that it's a lower cost process than maybe some of the other recovery technologies for metals. So finally, so I just put together all of the last ones here for the wastewater products. So biodiesel is actually an emerging area. So perhaps from restaurants or from food and beverage manufacturing, where they've got a high content of fats. So I know it's probably already being done in a lot of areas, but obviously this is being collected and reused in various different forms. So the production of biodiesel now is becoming quite popular. I know with well, fuel prices obviously fluctuate, but with rising fuel prices, this becomes a more interesting prospect. Some companies I've seen can take a very high free fatty acids content. So basically they can handle a much dirtier much dirtier oil. So it doesn't have to actually be quite a clean oil from a deep fat fryer, as it were. They can take stuff from like steel rolling oils. Another area is bioplastics. So obviously we're all keen to replace our polymers with petroleum-based polymers, sorry, with biopolymers. So there is a way to produce PHAs from sludge. So you can grow bacteria that will produce PHAs, and then you can harvest it. It has been developed in early stages, and it has high profitability predicted, but it's still quite a delicate process, and so it's kind of still in development. Construction materials, this is undeveloped market again, but sludge and stuff can be dried and then incorporated into various construction materials. So construction materials are so cheap that actually this is not really a profitable area. Protein is another potential area. This works in countries where there's a high density population and there's a need to generate a huge amount of maybe animal food, and so protein can be grown in sludge and then made into animal food. And there's other ones as well. So around there's obviously carbon capture, hydrogen generation. So these sort of technologies are all also on the horizon and being looked at, but they're not exactly economically feasible at the moment. So just to summarize, the market basically is key. So that drives your technology development. And so the biggest market basically is for water at the moment. So clean water is key for everyone. It's key for manufacturing. It's key for people's lives. And so there's a clear and obvious driver here to recover water wherever possible. There also might be drivers around just wanting to have a reliable water source, or ensuring that you've always got water for your manufacturing process, because I know that can be a showstopper if you're having issues. After that, so biogas and biosolids are kind of the key ones that are being used by a lot of companies at the moment. The drives to generate biogas will drive sort of drying of or enhanced sort of digestion processes and other treatment processes like anaerobic MBR, especially where land is restricted and there's no disposal of those biosolids. So they may even drive actually sludge destruction technologies, and it could be coupled. Sludge destruction technologies could be coupled with other waste streams, so maybe plastics or other sort of packaging waste that you have. So it could ultimately mean that you could mix in your biosolids in with those other wastes to produce biogas. So yeah, so this biosolid side again, there may be a drive. There's obviously a sludge to land angle with your biosolids, and it's a good way to get your nitrogen phosphorus into as a fertilizer into a land aspect. But if you have high trucking costs or high transportation costs, then drying, dewatering, or perhaps converting those biosolids into a pelletized sludge format is obviously an interesting way to look forward, especially if you're close to a business. If you're close to a cement business, then that's definitely an interesting way forward. Though, like I said, depends on your wastewater stream and what you have in there. And yeah, we'd be happy to talk to you and help you work out perhaps which technologies fit the best. Thanks, Jane. Thanks, everyone.
Thanks a lot, Karen. That was what we call a technology flash. We try to present in as little time as possible the many technology options available for companies. And again, it should be fit for purpose. You know, what is most appropriate for the kind of production that the end user has, and what opportunities are derived out of that.
Yeah.
Right.
Definitely.
Let's thanks a lot, Karen. let's dive into our first case study, which is the Singapore water story. I'd like to invite Ryan Yuen, the Deputy Director, Industry and Technology Collaboration Department of Public Utilities Board, the National Water Agency of Singapore. Ryan?
Thanks, Yang, and good afternoon, everybody. So this afternoon, I will basically give a brief overview on our experience in the circular resource management and resource recovery efforts. So, Yang, will you be controlling my slides? Can I have the next slide, please? Yang, can you hear me?
So you're probably not seeing this on presentation mode, so I'll have to keep it like this if that's okay.
Okay, fine. Then I'll just go on to the next one. Okay, so
all right, go ahead.
Yep, sorry for the delay. Okay,
No
so
worries.
PUB, as introduced by Yang, we are the National Water Agency of Singapore. And so as the water agency, we are responsible for the entire water loop. So we supply drinking water. We are also responsible for the collection of wastewater. We are also responsible for management of stormwater and floods control. And we are an agency that sits within the Ministry of Environment and Water Resources. And our sister agencies are the National Environment Agency that looks at waste and environment. We also have the Singapore Food Agency that looks at food. So interestingly enough, when Yang spoke about the waste, energy, and waste, food, and water nexus, actually you get all the three agencies all located within the same ministry. And actually that is the intent to actually harmonize and to try to build synergies across the agencies and their responsibilities. So next slide, please. So I think in Singapore, the issue of, in general, the issue of circular economy and resource recovery is a complex one, right? And it involves multifaceted. And I don't think even in Singapore, we have all the solutions. I think we have started, in fact, some of our earlier practices, I think in terms of even wastewater collection and treatment, there are some principles of recovery already built inside. But I think moving forward, there's a lot of emphasis within PUB on resource recovery and the need to apply a circular resource management concept. And I'd like to explain why from three angles. Number one, we are a island city-state. We have about 5.5 million population. But with growth and with industry growth, our water demand is projected to increase up to 2 times, right, from the 2018 demand. And of course, as we all know, with increased water demand, you actually will require more energy to treat and supply the water, drinking water, but also in terms of the collection and treatment of the wastewater. And with increased wastewater as well, you then end up with a problem of increased sludge as well. So I guess from a longer term strategic point of view, business as usual, right, with the same current mode of operation is probably unsustainable. And how do we meet this water demand? And our internal long-term goal is to see how do we meet this demand while keeping to the same energy footprint and also the sludge footprint. So I would say that in terms of how we tackle this issue of resource recovery, I think to kind of simplify it is about closing the loop. So I would like to explain our strategy in terms of closing of 3 loops: the closing of the water loop, closing of the energy loop, and maybe the closing of the nutrients group loop. So next slide. So I think most people will be familiar about the water loop. The typical water loop is highlighted in blue, where rain falls and then we collect the water that comes from rain. It goes into collection bodies like reservoirs that is used to then supply drinking water to domestic and industries. And thereafter it's collected back and treated. So in Singapore, we are 100% of population are served with drinking water, and I think almost 100% are also provided with modern sanitation. And I think that is key. I mean, the fact that it's 100% sewered and all our wastewater is collected allows us to close the water loop, because really the concept here is about loop, right? About a circular loop. And the only way to have a circular loop is to be able to collect every drop that's being used and to treat it and to reuse it. So in Singapore's case, we have invested in the early days the sewer sanitation system, and that allows us to now introduce what is known as new water or high-grade reclaimed water as an additional source of supply. And this source of supply goes into mostly to our industries. In Singapore, we do not have agriculture. We have a lot of advanced manufacturing, like wafer fabrication plants. We also have a lot of aircon cooling, because a lot of our buildings are served with air conditioning. So so new water goes to supply some of this industrial demand. We also introduce a part of it back into our reservoir. So closing the water loop actually allows us to introduce reuse as a possibility, and that enhances and strengthens our resilience in water supply. The next slide. So what is new water? Actually, new water is just reclaimed water. And I believe, I think Karen mentioned briefly some of the technologies that can be applied. In Singapore's case, we decided to put in a multi-barrier process where we include a microfiltration, RO, and a UV disinfection. I think simply because in Singapore we decided that the reclaimed water should be of high grade as possible. But I think the concept here is to be fit for purpose. And if you're using it for other purposes that doesn't require such a high grade water, then it all depends on what technologies you put in. But in Singapore's case, because we intended it to be an additional source of supply for industries and homes, that's why we put in this multi-barrier technology to achieve a higher grade water. Next. So new water then forms one additional source of water supply. As you can see from here, we actually do have 4 sources of supply. The rightmost 2 taps are actually from natural sources. The rightmost one is basically the water that we collect from the rain. The second from the right is water actually that we buy from neighboring Malaysia. But again, this comes from natural sources like rain. The left 2 taps are actually what are known as drought resilient taps, which are taps that would not run dry, in the event of extreme weather events, be it floods or droughts. And that will be how we build the resilience, and in effect, that is really the solution for us to close the water loop to ensure that there's water sustainability. So new water is what I just mentioned earlier. The other one is actually desalination, which everybody knows is about desalting water from the sea. Next. So desalination, as you all know, is energy intensive. As I mentioned to you earlier on as well, I think a lot of the processes involved in supplying of water and treating of wastewater is also energy intensive. So as a small country, in terms of closing the energy loop, we are also putting a lot of efforts here. And this is one of the example that we are currently in the process of building, which is called the Tuas Nexus. And the concept here is to bring together a wastewater treatment plant. We call it the Tuas Water Reclamation Plant, and locate it side by side with a waste management facility or waste to energy facility, or really in a layman term is an incineration facility. And really the idea here, as I mentioned to you as well just now, right, because we sit within the ministry, and the ministry actually oversees both the waste agency as well as the water agency. So because of that synergy at the ministry level, we are able to then plan and co-locate these 2 new facilities side by side and read the synergies. And the intention is then eventually with the co-location for the water reclamation plant to be energy self-sufficient. So what it means is that the liquid waste stream from the waste management facility plus the power that is generated from the steam that could be then used to power the operations of the wastewater treatment plant, and vice versa, the watered sludge, biogas, and a lot of the solid waste that comes out of the wastewater treatment processes can then be supplied into the waste management facility, again to use it as a resource to generate electricity and energy. So it's kind of a loop, and I think and that is the next frontier of closing the energy loop that we are doing. Next slide. And I guess I can't reiterate the importance that we actually are able to do all this simply because we actually do have a collection system, a modern wastewater collection system that is known as a deep tunnel sewage system. Because if you don't actually do have a system of collection, I understand the Philippines, there are certain parts that are sewered, there are also many areas that are on septic tanks, and I guess every country has its own different unique circumstances. But for us, the fact that we're able to collect every drop of wastewater will allow us to develop some of these capabilities. Next. Besides the TWAS Nexus, one of the interesting things that we have recently embarked on is, we have about 14 reservoirs located all over Singapore, supplying water that is from rainfall. And so these reservoirs are just sitting there most of the time, just collecting rainwater. And so what we have done recently, in fact, is only implemented, I think, over the last 1 or 2 years. We were actually building floating solar panel systems onto our reservoirs, because the reservoirs are actually large surface areas and most of the time they are unused. And that actually helps to generate enough energy to support the operations of the reservoir, and as well as supplying additional energy back to our energy grid. And then finally, I guess we are always in search of additional ways where we can reduce energy dependency. I have told you earlier, and desalination is one of our sources of supply. So how can we reduce the energy consumption from desalination is also key. And that is a lot of efforts in terms of R&D are being put into researching and developing alternative solutions for achieving low energy desalination. Next. And this is actually, before I come to my end, this is probably one of the last slides. So I think early on, Karen spoke about as well about the biosolids and the biogases that are generated, and then these are precious resources that should be recovered and reused. And I think I agree with that. In Singapore's case, because land is scarce, right? We are only an island state. We only have about 700 square kilometers of land, which is really, really, really small. And so we are going to run out of dumping ground. So any way that we can use to reduce the waste that goes into our dumping facilities would help. So in this case, we are looking at how do we use R&D to reduce sludge, as well as to recover some of the nutrients that are still present within the sludge. I understand that because of time, I don't actually have the luxury of going deep into some of these issues. But I would also want to say that I think as Singapore, even though we have embarked on a lot of these initiatives, we are also learning. We are still learning, in the process of learning. And that is a reason why, Yang, if you go to the next slide, we have organized Singapore International Week since 2008. The idea here of Singapore International Water Week, which is a biennial event, is to actually bring together some of the leading world experts and also some of the practitioners to have a dialogue. And the dialogue is not to benefit just Singapore, but I think the intention is to use an international event like Singapore Water Week to benefit the region. And certainly, we also hope that some of the discussions at SIWW will benefit some of our colleagues over in the Philippines. So I just wanted to use this opportunity to just share that the next Singapore Water Week will be coming on next year in June 2021. And next slide, the final slide that I have. is also to say that we are also using the opportunities during COVID to also introduce a few webinars. So coincidentally, when I got invited by Yang to speak as well, we were also planning a webinar on circular economy and resource resilience, moving from linear to circular resource. And that would happen next month on the 7th of July. And you'll be happy to note that actually we do have a speaker from the Philippines in the panel, Mr. Jose Rene Almendras, the President and CEO of Manila Water. And other panelists will include my CTO, my Chief Engineering and Technology Officer, Dr. Pang, as well as Diane, who is the CEO of Portland, Oregon Clean Water Services. So I would like to invite participants, if you're interested, to also join us in our webinar. The sign up is actually can be done via our social media posts, either LinkedIn or Facebook. So with that, thank you very much. I hope that I have given you a brief insight. I would have loved to cover more, but I think maybe if you join us at a webinar, we will maybe have the chance through our CTO to give you a bit more breakdown in terms of some of the solutions and technologies that we are using. Thanks, Yang.
Great, thanks a lot, Ryan. Indeed, there's a lot to talk about resource recovery and circular economy, especially from the Singaporean context. And this webinar that you have on July will be a great follow-through on the discussion that we have here. We're now moving on to our second case study on plastic to fuel technology. So we're going to shift gears a little bit because we've been talking about the water and wastewater stream. But we're going to move into the solid waste stream just to see a similar case study on plastic recovery and reuse. And to talk about that, we have engineer Noel Melarpis, a sustainability manager, water and energy of Pepsi Cola Products Philippines. Noel?
Thank you, Yang, and good afternoon to everybody. So the issue nowadays is plastic because these slides are from the internet. So worldwide, almost 5% of the plastic we generate is only recycled. So the rest goes to the ocean. So now we have an ocean of plastics. So and every year on year, the plastic consumption, especially on the single-use plastic, it grows every year. So now the direction, since the plastic came from the petroleum, so we will make the plastic as a petroleum product. So now there are technologies to make the plastic as a diesel or gasoline. But the question now is, if you have your car, will you use diesel from plastic? So your investment for your personal vehicle is too big compared to be as to use the diesel coming from the plastic products. So now moving forward, the industry which uses the bunker or the much cheaper fuel is opportunity for the use of this fuel from plastic. So looking for the type of plastic, there are 7 plastic we produce. So
Noel, before moving forward, could you share your screen so we could take a look at your slides?
See my slides?
No, unfortunately. I could do it from my screen, but I won't be able to play the video. So please go ahead and share your screen.
Let me check. Huh?
Yep, we've seen it. There you go.
Okay.
All right, please carry on. Thank you.
So as I mentioned, there are 7 types of plastic. So for Pepsi Cola, we are producing more on the PET. And most of the plastic that we recovered is only the type 1 and the type 2, which is the PET and the high density polyethylene. These are the plastic packaging. If you look at the toxicity level for the PET, so it's toxic. The best to recover is the HDPE. So in the recycling plant, this is the most expensive. And now they are trying to use the LDPE. So now this making money in the in the recycling plant. So plastic is made from petroleum, so we will make the plastic waste to petroleum product. So fortunately for us in the Philippines, we have one inventor named Jaime Navarro. I don't know if you read it in the internet. He invented the process to make the plastic from fuel, and he made some several plants here in the Philippines. Unfortunately for us, we are trying to connect with him, but we cannot locate him. Even in his website, we do not have his contact number. Even the Polygreen Technologies company, there's no information where to contact them. So from that, we try to look in the internet. So China now, they also have now plants. They are selling plants to convert plastic to fuel. Unfortunately for China, they are not confident in using the PET as the raw material to make plastic to fuel. So we are fortunate here in the Philippines. We discover one in Zamboanga. So this is his plant. So he is now producing plastic coming from mixed PET and type 1 plastic. So now we are getting some diesel fuel from this plant, and we make it use as fuel to our boiler. We mix it with the bunker fuel nowadays. And recently, this company now, they sell also diesel fuel from other industries like GSMI and Bounty Press. So I want just for appreciation, I just want to show the video. So we throw the liquid fuel and the soil, and then we started to fire it. And if you can notice, if you compare it gasoline and diesel, it will not burn on the soil. On the soil. But this is like the grade of the fuel they produce is better than the gasoline product. So it is promising considering the volume of plastic that we generate, and also this will give opportunity or livelihood for our local government unit and community to collect plastic and sell it to the recycling plant. I think that's also just to summarize. We try to minimize the use of plastic. If possible, we use RGB. So fortunate for Pepsi Cola, our business, we use mostly RGB. So less than 30% as plastic, unlike our competitors. So now, looking forward with the increase, like Yang mentioned earlier, progressive legislation. So we expect in the coming months or coming years, we have new laws that will give a financial difficulty in on the plastic products. So now we try to support the local supplier like Jaime Navarro to buy their products, the diesel from plastic to use it in the industry. As of now, we cannot use it in our vehicle, so it's a big impact for us if our engine was damaged. But for the boilers and generator, so it is not sensitive on cheap fuels like bunker C. We can convert from bunker C to diesel coming from plastic fuel. So that's my presentation for plastic to fuel. And thank you.
Thank you very much. Well, that was very informative, short and sweet. And we are just right on time for our Q&A. Let me share my screen again. There you go. So we've got a few questions from the YouTube live chat. And for those who'd like to ask more, feel free to chime in on the live chat on YouTube. And I've posted the other reminders here just for everyone to see. So I'm going to pick out the first question, which is from Vincent Jeff. He asked, do you have any information on the current extent of the biosolids business in the Philippines? Are there regulations governing the control of contaminant concentrations in the biosolids? To my knowledge, yes, there are regulations on biosolids and nutrient concentrations, particularly on the agricultural sector. We personally have not conducted any studies on this. But I'd like to ask, in the Singaporean or Australian context, Ryan, Karen, if there have been legislation that have pushed companies towards biosolids recovery.
So I can talk just about the municipal market. I know that there's been some new legislation in Queensland in Australia, just around end of wastes. They've kind of adopted more of a kind of a product view of that biosolids. So the idea, and so a lot of companies are looking towards, okay, what can we make of a product of a biosolid? So what can we make that's a better product for our farmers? So that's kind of pushed it. There's a certain contaminants. So in Australia, there's an increasing awareness of PFAS and PFOS. So they tend to be the key contaminants now that everyone's sort of conscious of in the sludge, and those contaminants might drive the move away from sludge to land to either more thermal treatment processes or alternative uses for those biosolids.
Well, in Singapore's case, there are strict regulations in Singapore with regards to discharge of wastewater, industrial wastewater as well as biosolids. So yeah, there are regulations governing it, and and there's strict enforcements as well.
Thank you both. I've got an interesting question from Insitare, asking whether, and the context is, the greatest barrier to nature-based circular economy solutions is scale and old ways of doing business. Can what was called the Asian way fast-track this shift? I'm not sure what the Asian way is, but just to paraphrase the question, I understand this as, can Asia leapfrog in terms of innovation and adopt these technologies perhaps faster or ahead of some of the countries? I'll turn over to Ryan. Based on experience, what is the opportunity for Asian countries to lead the way in resource recovery?
I mean, I can only speak from Singapore's perspective. I guess, yeah, scale really matters, right? At the end of the day, but I guess it's a combination of a lot of factors. It is about technology, it's about regulation, it's about enforcement, it's about pricing, and so I don't think there is a silver bullet. I think it just has to be a combination of different factors. Certainly in Singapore, I would say that our situation is a bit unique in the sense that we are a city and a state, right? And we have one utility, right, that manages the entire water loop in Singapore, and so that allows us to, in terms to implement things at scale, and also allows us to, and also as a government agency, right, allows us to put in place regulations, to deter some of the practices that are probably undesirable. For example, you talk about contaminants and the discharge of illegal or wastewater, and so some of these things, it's just that in Singapore's case, we have a lot of some of these factors that are aligned, and it's just. But I would say that in general. I guess so. If you look at it, if I could say, put my hats on and say that, if you look at Indonesia, China, I believe, and even the Philippines, I think there's a lot of potential. But I think a lot of the pieces need to be in place before we can even start to talk about implementing at scale.
Thanks, Ryan. And I think that goes back to our point earlier that it really does need a bigger picture systemic thinking. And Singapore is well placed to do that because all of the water, energy, food sit under the same environment ministry, and that makes action much more coordinated than it is for other countries. And that is perhaps one of the most important lessons for us to learn. We've got a technical question from Ryan, and this can go to Karen. Do the recovery processes that you mentioned in the technologies entail greenhouse gas emissions?
So they can do. So if you're looking at, typically nitrogen removal technologies, they have a bit of a bad rap in terms of producing an excessive amount of, if you're removing the nitrogen, sometimes you're removing it to nitrogen oxide or nitrogen gas, and therefore that's nitrogen oxide is a greenhouse gas. It's a lot worse than carbon dioxide or methane. So in that circumstance, yes, you might be, if you wanted to reduce your greenhouse gases, maybe you'd be looking at algae technologies instead of having sort of anammox type technologies to remove your nitrogen. So moving to something that encapsulates or traps that nitrogen, maybe a way forward in your resource recovery. So it's definitely something to consider. The same with any thermal sludge destruction processes, sludge, producing, you want your methane to escape, you want to be able to capture it as a biogas. If you're just destroying your sludge and producing that biogas, you're obviously maybe putting it into an engine, or you may be burning it to create heat and steam. So in those circumstances, you may be then looking to capture your CO2. I know this is something that Noel's looking into or is doing at the moment. So it's, there's a lot of capacity here. If you've got a carbonization process, you're producing a soda, then be able to capture that CO2 is a great way to have that full circle and reduce your carbon emissions.
Thanks, Karen. I'd like to turn to Noel and ask his thoughts about carbon footprints of an industrial company. And obviously, there are going to be trade-offs between reducing water footprint, reducing energy, but upping, for example, your carbon footprint. How do you manage as sustainability manager these trade-offs? Which ones do you prioritize, and what's important for you as you move forward in your sustainability plans?
For energy, it is more easy to justify the activities, the initiative to reduce the energy and footprint, because energy is expensive, both fuel and electricity. But for water, the challenge with the water, it is considering the pumping cost, it's very cheap. So the investment for the water initiative, it takes around 18 to 20 years. But looking at the company policy to reduce the water consumption, so in order to hit your KPI, one of the major objective of the company, especially for Pepsi, that almost 95% of our product came from water. So the direction to hit the target was it is not it is no price. So whatever we can save, we have stages in reducing the water. Like for example, first is to avoid. If you can avoid the use of water, then do it. Then secondly, if you cannot avoid the use of water, then try to reduce your consumption. Then there comes when this low-hanging fruit was implemented already, then you have to go to the reuse or recycle, which need more investment. So what we did with the help of PepsiCo, we tried to benchmark some best practices in PepsiCo International. So we implemented it in PCPPI. So it depends on the policy and the directions of the company. But yes, it's very challenging for water. But without water, so there's no life here on Earth. So that's maybe that's one of the major objective for water reduction. For energy, it's easy to justify, easy to prioritize, because fuel and electricity was very expensive here in the Philippines.
Right. Thank you, Noel. And we've got a couple more questions. Unfortunately, we don't have time to go over them all. We've got a question, for example, on which ones of the technologies presented contribute to climate resilience or climate change adaptation. We've got a question on case studies on the Clean Water Act, and we've got a question on blended finance. All of these are very interesting inquiries, and we will try to post answers through the IL Utilities and or the PBSP page, and we can also send your answers via email. Unfortunately, that's all the time we have for a live Q&A, and we thank everyone for very actively participating and for being interested in the topic. I'd also like to thank our speakers, Karen, Ryan, and Noel. Thank you very much for being part of this event. And we are looking forward to more of these discussions, as Ryan mentioned, in the July 7th webinar in connection to the Singapore Water Week. If you'd like to know more about PBSP Water Alliance, please get in touch with Kathleen Almonte on this email. And of course, if you've got questions on technologies and innovation, please feel free to reach out to me via this email. And again, I'd like to thank everyone who's tuned in. This video will be available for you to watch on demand and rewatch if you'd like. Please feel free to share as well to your colleagues and who are interested to watch. All right, so I'd like to wish everyone a happy weekend, and please take care. And we'll see you in the next Sustainable Water Solutions webinar. Bye for now.
Bye, and thank you.
Thank you, Yang. Thanks, everyone.